So again, we need to show that this thing is decreasing, so a sub n plus 1 is less than a sub n. This is 1 over n plus 1. The ln of n plus 1 is less than n ln n. Not real easy to show that this thing is going to be decreasing. Can't really do it by playing around with some inequalities. I really have to use some calculus here to get this derivative to work. Just a quick question, why did I start at 2? Well, that's because if I plug in 1 here, I get 1 here, and the ln of 1 is 0. It can't have 0 in the denominator, so that's why this series starts at 2. So I'm going to rewrite it as f of x equals 1 over x, the ln of x. And I think probably the easiest way to do this is do a little chain rule here. I don't feel like dealing with the quotient rule. So therefore, my derivative is equal to negative x ln x negative 2. That's just the derivative of the outside. The derivative of the inside is a little product rule. I get the ln of x minus x times 1 over x, right? So this is f prime of x is equal to, I'm going to put this thing in the denominator. I'm going to leave the negative up front. This is just the ln of x minus 1 all over x ln x squared. So my denominator is equal to 0 if x is equal to 0, right? So f prime of 0 does not exist, and f prime of 1 does not exist, but that doesn't really matter because, again, my series starts at 2. My numerator here, I'm going to set equal to 0, so ln of x minus 1 equal to 0, ln of x is equal to 1, x is equal to e. So therefore, I need to show that this thing is decreasing on my interval, right? So here is my interval here. I don't know why I drew that vertical axis. Here is infinity. This is 0. This is e. And I needed to start at 2, right? So this is just one of those weird problems of, oh, well, it's probably going to be decreasing from 2 to e, and then from e on it's probably going to be increasing from 2 to e, and then decreasing from e beyond. But let's just test here. So I need to pick a value to the right of e. E is 2.7, so I will do 3. So f prime of 3, using this thing here, is negative ln of 3 minus 1 all over 3 ln of 3 squared. The ln of e, is 1, right? So this thing here is just ln of e. 3 is bigger than e, right? But that's why we chose 3. So the ln of 3 is going to be bigger than this thing here. So this whole numerator is going to be negative. This thing is definitely going to be positive. So therefore, my series is decreasing on this interval. So really, this problem should be written as the following. I need to plug in 2 here, so it should be 2 ln 2 plus I should have a new series where n is equal to 3 to infinity 1 over n ln n. And the convergence or divergence is not really going to be affected by having one additional very small term, 1 over 2 ln 2. Remember, again, you're dealing with infinities here. This is not really going to affect it at all. So therefore, is this series decreasing? Well, not in its current form, but if I just take off one little teeny tiny term, I can now make a decreasing series. And notice that I really couldn't do this by playing around with n's and n plus 1, excuse me. I needed to do the derivative and show that the derivative was negative. You need to always check your denominator values to make sure they're not equal to 0. It didn't really affect us, right? Because 0 and 1 were way over here, and we were starting at 2, so 1 didn't really affect me. Didn't need to worry about that too much. And if I knew it's decreasing from there beyond, I can just peel off this term right here, and then I have a decreasing series. So this guy's decreasing if I just take off that one little term right here. It doesn't happen very often, but it's just something you should be aware of.